Alright, 8th grade, so we're going to go ahead and talk about Test 13.5 Study Guide. And problem number 1 says that we want to find the range that contains the value of the square root of 200 plus 70 minus 10. So the first thing we want to do is we want to simplify the inside. So whenever I have subtraction, I just draw two sticks, make it, do add the opposite, row for subtraction. So I can use teams. I put all these numbers on teams, right? I have positive 200, I got positive 70, and negative 10. I'm just going to add up all my teams, right? I got 270 positives, 10 negatives. Opposite team subtract. 270 take away 10 is 260. But since there are more positives than there are negatives, it's positive 260 instead of negative 260. So all this stuff means the same as the square root of 260. So now I have to ask myself, the square root of 260 is about what? So I start looking at narrowing it down, right? I start looking at perfect squares. 10 times 10 is 100. Well, 100 is smaller than 260. 20 times 20 is 400, not 40. Sorry about that. And that's bigger than 260. So I already know that it's in between 10 and 20. We memorized 15 times 15 is 225, so look, that's real close. So that's where I start guessing. So I start out with 16 times 16, 256 is still too small. Remember, I have to find one that's too small and one that's too big. And then we have 17 times 17, which is 289. So 16 is a little too small, 17 is too big, 16 and 17 are right next to each other. So that's why it's in between 16 and 17. So 16 point something, right? So that right there is enough to answer. The answer has to be B. But if you wanted to narrow it down further to estimate this irrational number to the nearest tenths, then you would say 260 is how far away from 256? It's 4 units away. It's 29 units away from 289, so it's closer to this side than this side. In other words, it's closer to 16 than 17, right? So it's got to be 16.1, 16.2, 16.3. It's not really in the middle, where it'd be 0.4, 0.5, 0.6, and it's not closer to the big side, closer to 17, which would be 16.7, 16.8, 16.9, which means that the answer, of course, has to be B. It's in between that range. So problem number 2, it says give the values for the numeric expressions 5 over 10, rad 25 over 5, and 2 pi over 2. And just like we said last time, you always got to simplify first. First thing we do is simplify. So 5 over 10, when we simplify 5 over 10, simplify 5 over 10, well, that's just 5 tenths, right? If you read it, it says 5 tenths, right? So that's 0.5. Now, rad 25 over 10, well, the square root of 25 is 5, and 5 over 5 is 1. So that's 1. This is 0.5, this is 1. 2 pi over 2, just cross out the 1s, right? 2 over 2 is 1, cross that out, and pi is about 3.14. So we know those about 0.5, 1, and about 3.14. Number 3 says enter the value for x, which makes this equation true. Well, when I'm multiplying powers with the same base, I copy that base and I add these two. So in other words, I'm trying to figure out 7 plus what is negative 2, because I got to add these two to get this. That's what I do when I multiply powers with the same base. So 7 plus what is negative 2? I can just solve that equation. Isolate x. Opposite of positive 7 is to subtract 7 from both sides of the equation. Negative 2 and negative 7, I'm adding two negatives, are on the same team. Negatives have more, so my answer is x is negative 9. Next problem, number 4 says evaluate, and we're going to evaluate this expression if a is 2 and 3 is b is 3. But you know what? B to the 0, it doesn't matter what b is. Anything to the 0 power is 1, right? So let's just cross out our 1s right now. Just hit that right away. Don't even worry about it. A to the negative first power, well, a is 2, so 2 to the negative first. Remember, negative exponent means flip it. Now it's 1 over 2 to the positive first, and 2 to the first is 2, so your answer is 1/2. Number 5 says the container holds 12 to the 6 grains of sand. There are 12 to the 8th grains of sand in your backyard. So how many containers do you need? All right, well, that's just a division problem. 12 to the 8th divided by 12 to the 6 means 12 to the 8th over 12 to the 6. Copy the base, subtract the exponents. 8 take away 6 is 2. There's your answer. Number 6, we're going to simplify this expression and see which of those 4 given expressions is the same. So first thing we do, we go on the inside. Again, I'm multiplying powers of the same base. I copy the base, 3, and add the exponents. Negative 1 plus 3 using teams is positive 2, right? Negative 1 plus 3 is 2. Now I deal with the outside. 3 to the second power to the negative first, that's a power next to a power. When they're next to each other, that's when we multiply. So first do the inside, that's where I add the exponents, then do the outside, that's where I multiply. So I got 3 to the negative second power, and if I were to simplify that, that would just be 1 over 3 squared, which is 1 over 9. So if I'm looking at the other expressions, expression 1, multiplying powers of the same base, copy the base, add the exponents, that's the same. Expression 2, same thing, copy the base, add the exponents, negative 3 plus 8 is 5. That's not the same, don't pick that one. Expression 3, 1 over 9, well we already simplified it, we know it's 1 over 9, so that's the same. And expression 4, 9, well that's not the same as 1 over 9, so just pick the answer that has expressions 1 and 3 as your choices. 7 says how many times larger is 5 times 10 to the 7th? How many times larger than 5 times 10 to the 7th is 4 times 10 to the 9th? Well, how many times larger is a division problem? We divide in and out, put the bigger one on top. Bigger one means exponent, right, not coefficient. So 4 divided by 5, I go in and out, that's 0.8. 10 over 7 divided by 10 to the 7th, again, that's just copy the base, subtract the exponents. 10 take away 7 is 3. So I got 0.8 times 10 to the 3rd. Again, always pause these videos and make sure you can do what I do before you move on. You can pause it, rewind it, play it in slow motion if you need to. Okay, so now we're going to put this in. It looks like we can put it into scientific notation if that's what they give us. That's the 3 arrows lesson, right? I forgot my 3rd arrow there. So in other words, this decimal's got to be moved one time, so it's 10 to the negative first because 0.8 is smaller. If it was 80, it'd be to the positive first, right? Then I multiply these two powers, I copy the base, add the two exponents. And of course, if they want the answer in standard or decimal notation, 8 times 10 to the second power means 8 with 2 zeros, or 800. So however they want the answer, you can do it either way. We learned how to do both in class. Number 8 says solve 3/4 W equals negative 1/2. Well, that was the first one we learned, right? Very first one is the hardest one. What do I do with a fraction in front? Flip that fraction upside down, multiply both sides. Cross out my 1s, that's why we did it, to get rid of that, to isolate that variable. And we know that multiplying fractions is as simple as doing our factor trees and crossing out our 1s. And we use Mr. Dude to get the sign, right? Negative times positive is negative. Number 9 says solve negative 8.2 or negative 8 2/10 P equals 49 2/10. Well, next 2 means times, so the opposite of times to divide. I go in and out, and I use Mr. Dude. Here's my division over here. You can check your work. Pause the video, make sure you can do it by yourself. You should get 6. Number 10, we're going to solve this equation. Now, work farthest away from the variable first. The opposite of positive 4 is to minus 4. Subtract 4 from 11, I get 7. And it's gone on this side. Now, how do I get rid of that number on the bottom? Well, over means division. All fractions are division problems, right? So the opposite of divide by 10 is to multiply by 10. Multiply both sides by 10, cross out my 1s. 10 times 7 is 70. My answer is 70. 11, we're going to find the value of x. In other words, we're going to solve this. This is a problem where we're not on step 3 like number 10. We're on step 2 because I got variables on both sides, so I got to get my variables on the same side first. So if I have negative 7x, if I add 7x, that gets rid of negative 7x. But I have negative 3x plus 7x. Notice I took the x with it, right? So now it looks like problem number 10. Now it looks like I have a two-step equation. Now I can work farthest away from the variable doing inverse operations. The opposite of negative 198 is to add 198. And of course I did rule for subtraction up here, right? We always do that first. I did add the opposite right here to get this step. Okay, so I add 198. 198 plus 2 is 200. Divide by 4. Our answer is 50. Number 12, we're going to find the value of x that makes the equation true. So in other words, we're going to solve again. And this isn't like 10 or 11. This is where we have to simplify first, because we always simplify first, right? So for 10 and 11, that was already simplified. This is simplified. This is simplified. I didn't have to do that there. But whenever you can simplify, you must do that first, which of course means to distribute first. But we set it up. We draw our elevator. My elevator had a little earthquake here, right? It got all bent up. So I did my rule for subtraction first. I did add the opposite, and parentheses inside parentheses, those become brackets. Now I distribute the 1/2. Half of 10x is 5x. Half of negative 8 is 4. That's how you distribute a 1/2, right? Just take half of everything in there. After you distribute, we combine like terms. Now 5x and 5x, since they're on the same side, I don't do inverse or opposite. I don't think subtract 5x. I just add 5x to 5x. That gives me 10x's. Now both sides are simplified. Now I would get my variables on one side, but that step's done for us in this problem. So I go to step 3, isolate the variable. Work farthest away from the variable. Opposite of -4 is to add 4. That will make that go away, which makes it one step closer to isolating that x. Just got to get rid of that 10 to isolate the variable. Dividing by 10 is as simple as moving the decimal one time. X is 11. 11 would make that true. Problem number 12, we're going to say how many solutions each of these equations has. So what you want to do is basically just simplify each side and then you can stop. So for this problem, both sides are already simplified, right? I can't distribute or combine like terms like I did in number 12, so they're simplified already. And I just looked. If I have different coefficients, there's going to be one answer. I don't need to find that answer. They just want to know how many answers there are. This has one answer. Why? Because both sides are simplified and my coefficients are different. This coefficient's a -1, this coefficient's a +1. That means one answer. There will be one answer. Equation 2, again, make sure both sides are simplified. This side's simplified. I can't distribute or combine like terms. This side's simplified. Look at my coefficients. My coefficients are the same. So that means one of two things. Either it's A, infinitely many, or B, it's no solution. So now I look at the constant. If the constants are different, coefficients are the same, there's no solution. Or, in other words, there's 0 solutions. Not to be confused with the number 0. That just means there aren't any answers for this. And for the last one, this is the same as this. Both sides are simplified. Same means infinitely many. That would be an identity, right? All real numbers. How many answers is all real numbers? Infinitely many numbers. Okay. So number 14, it says we're going to go ahead and find the constant rate of change. So I just do y minus y over x minus x, right? Y minus y over x minus x. Simplify, and that's it. 15, we're going to say what's steeper. So if I look at the graph has a slope, right? I can take 2 points from the graph, and I can do y minus y over x minus x. I go 24 minus that over 1/2 minus 2.5. And then I can do 24 take away 20 is 4. 1/2 take away 2/2 to do the rule for subtraction, convert 2.5 into a fraction. We already have common denominators. Use teams for the numerators. Negatives have more. So I have 4 over -4 over 2. -4 over 2 is -2, right? 4 divided by 2 is, you can do factor choose, cross out your ones. And then 4 divided by -2 is -2. So that's one way to do it. Or you can just take a graph and you say, each one of these guys is worth 4, right? I go down 4 and over, well, each one of these is 1/2, so it's half whole. Down 4 over 2 would be a -2. You can do it that way also. Now, if you look at the table is proportional because we have 0, 0. So I can take 1 point, put y over x, and I get a slope of -12. A slope of -12, that's steeper than a slope of -2 because we look at the absolute value, right? We pretend that they're all positive because I just want to know how steep it is. It doesn't matter if it's a negative slope. And so since 12 is more than 2, it's going to be a steeper line. So next problem, for number 16, they ask us which equation is proportional. Well, we learned in class, and you actually learned this in 7th grade too, that for proportional lines, they all have the same equation. It's y equals slope x. And if it's proportional, they're all going to look like that. So it doesn't have to be y and x, though, for 16. So the only one that looks like that has a letter equals a number next to a letter is D, right? This one doesn't, because when I isolate the y, the x is going to be on the bottom, right? If I divide both sides by x, x is on the bottom. That means x to the negative first. This one's not. It's a line, but it's not proportional because it's a +2. This one's not because it's m squared, so the only answer is D. 17 says, write the equation for the line. So I got to get the slope first. I can take 2 points. I go down 3 to the right 2. That's a slope of -3 over 2. I see the line hits the y-axis at -1 at that point at -1, so my b is -1. I put the m where the m goes, the b where the b goes, in y equals mx plus b. That's the slope-intercept form of a line. Put the m here, the b there, and that's it. So for 18, they want to know which ordered pair is the solution. So here's my equation. So I take each pair and I plug it in. Okay, this is x, this is y. I put the y where the y goes, the x where the x goes, and it looks like this, and I simplify. I multiply fractions, cross out my ones, use teams, and I see that 1 equals 1, so for the first problem, that is a solution because I plugged the numbers in and I got a true equation. I got the same number on both sides. For ordered pair number 2, they give us 2/3, so I plug it into the equation. Y equals 1/2 x plus 2. Y is 3. 1/2 is, they gave it to us. X is 2 plus 2 is from the equation. Again, simplify. 3 equals 3. Yes, it does. That's true. So that second point is also on the line. In other words, that second point is also a solution to y equals 1/2 x plus 2. Third point that they give us, 0, 1/2. 0, 1/2, if I plug it in, put the y where the y goes, x where the x goes, simplify. That's not true. 0.5 doesn't equal 2. That means that this point is not a solution to the equation. And the last one, again, plug those in. Since this is not true either, that is not a solution either. So you just plug the numbers in, simplify, and see if you get the same number on both sides. If you do, it's a solution. If you don't, it's not. 19, we're going to write an equation. First thing I got to do is find the slope. I do y minus y over x minus x, y minus y over x minus x. Add the opposite in teams, and I get a slope of -2. So now that I have a slope, I need to get the y-intercept, because the two things we need to write an equation are the slope and the y-intercept, and then we plug it into slope-intercept form, right? The slope goes here, y-intercept goes here, and that's it. That's the equation for a line. Found the slope already, don't have the y-intercept, so I take one of the 2 points, it doesn't matter which one, and I use y equals mx plus b. I'm going to plug the x where the x goes, the y where the y goes, the slope that I found where the slope goes, and then all that's missing is the b, which means I can solve this equation and find b. So now that I know what m is, and I know what b is, I put the m here and the b here, and that's my equation. Notice that when we write the answer, we put the y and the x back in. We don't put the 2 and the 0 back in, or the 1 and the 0 back in. Because the x's and y's vary, so I got to put letters there. What doesn't vary is the slope and the y-intercept. There's only one of each of those, so that's why numbers go here and letters go here for the equation. Number 20, what's the solution? Well, that's just as simple as seeing where those two lines intersect. They intersect at -2, 4, and that's the solution. All right, 8th grade, hope that helped.